Well, thank you very much. Thank you guys for joining us today. As Ms. Celia mentioned to you, my name is Bob Mitchell, and I'm a account manager for Purkeys for the Southeast, and we have Larry Rambo here as well. Larry is our sales application engineer. We're going to be talking about cold weather, how we should prepare our fleets for cold weather. As I said, I'm from Florida. Cold weather means anything below 60 degrees, but I understand other people in parts of the country probably have it a little worse. So winter's coming around the corner. Electrical systems are one of the main components that are affected by those cold temperatures. And before we get going any further, if there's ever any questions throughout this presentation, obviously type it in. Larry and I are both checking the questions box. So anything specifically you want to know, we'd certainly would be willing to answer for you. So in warm weather, things are easy. Got the easy button going. Cranking amps are much lower. Your battery requirements much lower. Everything's kind of moving nice and easy. Electrical system is taking it easy, as it should be, anything above 80 degrees. But the bad side of that is winter's coming. Game of Thrones says winter's coming. Well, it is throughout the year. Winter is difficult on the electrical systems because the cranking amps can triple. You get increased stress on the starter, increased stress on the batteries, and voltage drop in cable will increase. I'm going to steal Larry's line here, but he doesn't like working in the winter and cold temperatures, and neither does your electrical system. So sorry for stealing that from you, Larry, but there you go. So what typically happens, and as you can see from this graph here, from this visual, at 80 degrees, your starter, your engine, your batteries are all operating about 100%. Everything's fine, like we said, taking it easy. Everything's moving as it should. As the temperature drops down, as you see it to 32 degrees there, your battery is only operating at about 85% efficiency, and your starter and engine are required 165% in order to get going. And of course, that gets worse as you get into the zeros. And of course, you get down below 20 below zero, you are really putting a strain on your batteries, putting a strain on your engine. So that's why we want to talk about kind of getting prepared for that. I came from Interstate Batteries. I worked there for a number of years. And we used to say that the heat will deteriorate a battery, but the cold snap is where it will disabilitate your battery and your system. So these people that first cold winter in Chicago, that first cold day in Chicago, that's when their cars won't start. That's typical of fleets as well. So got a little poll question right off the bat here. We'll go early and see who's awake already. What equipment can benefit from a good PM? Got a number of different answers here. Go ahead and take a minute and interact here, and which pieces of equipment, more than one answer can be correct, would benefit from a good PM. I'll give you a minute. All right, well, we didn't hit you with too tough of a question right off the bat, and I probably gave the answer away when I said there was more than one correct answer, but yeah, all of the above. Your trucks, your reefers, your liftgate batteries, all of these pieces of equipment can benefit from a good PM, making sure that your systems are where they should be and operating correctly, and Larry's going to speak a little bit more about that later on. But let's take a look at how batteries are impacted. So we have here your typical set of Ford's Series 31 batteries that are set up here. On a warm day, they're all operating, as we mentioned before, at 100%. The starter draws about 650 amps from the batteries, and so each battery would supply about 162.5 amps. Everything's fine, no problems. Not going to see too many issues on a warm day like this. But let's turn the page here and see what happens on a cold day. So as the temperature drops, that starter is going to be drawing 1,700 amps as opposed to the 1,650. So more than double in order to get it cranking. and each battery would need to supply 425 amps instead of the 162. So you can see the effect it would have there on the batteries and on the starter. So we're requiring more to start, and we're getting less from what we're requesting. So how is the starter impacted? Load can more than triple in cold weather. And there again, depending on going back to the scale we just showed, whether it's 32 degrees, 0, or even below 0, puts a lot of stress on the starter, doesn't spin necessarily as fast. And the voltage drop that you're getting equals a loss of cranking speed. There again, it's not cranking, it's not turning over, it's putting a lot of stress on that starter. And the rule is, as voltage goes down, amperage goes up. So the volt, and what we also talk about here, and Larry will speak to this a little bit more too, is you get a voltage drop in the cranking cables. So not only is the battery not putting out as much, it's moving through a slower. The cables are cold as well, and they're tying up some of that energy. You're getting reduced cranking speed there. And a lot of people don't think about the cables. They think about the battery, think about the starters, but your cables are affected a great deal by that as well. So, for example, as we're talking about checking the system here, so we got warm weather. Everything's good. The TMC RP129 spec is at 500 amps. They allow a half a volt maximum drop. So that's perfectly acceptable. You get a half a volt drop running through the wires. That's well within reason. Again, in warm weather, the starter pulls 600 amps. The truck is getting 10.5. It's getting 11 volts, and at the starter, we're getting 10.5 volts at the starter. So that's well within the half amp drop that we just talked about. But then you test the system in cold weather, and there again, we get the RP is get a half a volt maximum drop, but the starter pulls 1800 amps. The batteries are not at where they were before. They're at 10.4, and you take that half of 9.6. Am I reading that right? 8.6, sorry, or 9.2 volts at the starter. So you're getting that drop there. So you can see how that would cause a problem for your starter to turn over. So the biggest issue with equipment is keeping the batteries charged. So just like we're talking about your batteries being able to push a charge or push voltage to the starter, the battery also has to be able to take voltage to recharge. And of course, during cold weather, that doesn't work well. Simply put, batteries do not want to give off their charge in cold weather. So, giving off their charge much like water, and then in cold weather, it runs much like a toothpaste, or just doesn't flow necessarily as well as it should. And that is true, as I mentioned before, that the battery's ability to accept a charge is greatly reduced. You're not going to be able to put the energy back into the battery as well, because it's moving sluggishly, it's moving slowly. The molecules are not excited there. And the alternator needs to be functioning, and the voltage of the battery pack is crucial. So the alternator needs to be pushing that voltage to the batteries, and the alternators don't work as well in the cold weather. So it's kind of a catch-22. Cold weather, as we said, can very detrimentally affect your battery production, putting voltage back in and taking voltage out. Charging systems are critically important in cold weather. It's basically what we're saying. The whole idea is that this cold weather is killing a lot of your systems. So we're going to talk about working on good PMs to make sure we're not affected by that negatively. So winter's a difficult task for that. Again, even in warm climates, we don't feel it as much, but there are cold days that we will put a hurt on our batteries, if you will. But there again, you guys in cold climates, you guys have to deal with this all the time. So charging system issues in trucks, you have idle restrictions, you got higher cab loads, and as cold temperatures affect those idle restrictions and those higher cab loads, people are putting more and more electronics into their systems there, and it's just causing you're overworking your batteries. Factor in the idle restrictions that your company has, available, and those cold temperatures are really going to affect those restrictions in those loads. So it affects the lift gates as well. Like going back to the survey that we had, we're right. All those systems are affected. Your lift gate batteries affected by this cold weather. They're doing longer cycle times. The power down is used more, and the colder temperatures are affecting their ability to cycle through those times and get your lift gate up and down. Reefers, they're going to run less during the cold weather because obviously it's cold outside, but there are parasitic loads on those reefers. Colder temperatures are going to sap those batteries as well, sap those systems, and recharging those systems as well, all going to be affected. So Larry's going to talk about our 1, 2, 3 approach on what we talk about on how to effectively prepare for these winter systems and for these dangers I just told you about. Larry?
All right. Thanks, Bob. Greatly appreciate the intro and all the setup for, why these things are important. One of the biggest things I always want to, stop and look at is the cranking and charging is a system. And as Bob said before, people worry about the alternator, they worry about the starter. A lot of times people forget about the cables, and that's just as important. So we kind of made this the 1, 2, 3, and when we do shop training, we call it the 1, 2, 3 training. I say, why do you call it 1, 2, 3? We going to learn our numbers? No, it's the whole idea is before you can test number 3, what do you got to do first? 1 and 2. And regardless of what you're working on, whether it's a lift gate, it's a reefer, a truck, a bob truck, whatever, number 1 is you just got to start with the batteries. If the batteries aren't right, nothing else is going to be right. So before you do anything is you got to make sure your batteries are minimum open circuit voltage or a minimum state of charge to be able to test them. With a lot of the newer testers, electronic testers, it may still allow you to test those batteries, but it's at least going to tell you you're still going to have to charge them and retest them or too low to test. It can still weed out some of them, but there is limitations no matter what. You got to take all the cables off. Again, there's a lot of electronic testers out there that can test battery packs. Those are very good pieces of equipment, but you still have to be, doing all your due diligence as we get ready to go into winter. So we're going to take everything off because not only are we going to test the batteries, we got to make sure everything's clean. That's, again, the batteries can be great. If we got bad corroded cables, loose connections, whatever, it's still not going to work properly. Got to clean the pad area. It's one of the things I see a lot of times in shops where they miss that step. That lead pad at the bottom of that connection there, the threaded stainless steel stud is only there as a mechanical connection. That lead pad is the electrical connection, so it's got to be clean. We're showing here there's a little battery brush you can buy from us or all kinds of different suppliers offer them. But they fit on a cordless drill just a couple of seconds, and they do a great job of cleaning that pad up. The other thing is you got to use adapters. Depending upon battery manufacturers, some of them request that you use a brass adapter because their pads are brass. Even if you use a lead adapter, you're going to be so much better off regardless of that tester's requirements. The lead ones are cheap, they're easy. The thing I do like about them is they're a little softer, so they're a little bit better about conforming if there's a little bit of difference in that pad. But it's got to get all the way down and make the connection. Again, many different testers out in the market, some very good manufacturers, but no matter what, you have to be familiar with that tester. You have to be trained on it. That there's a lot of intelligence built into these, but you got to make sure you're answering the questions properly. One of the biggest ones that all the electronic testers ask you is the temperature. What gets techs in trouble sometimes is they're assuming they're talking about ambient air temperature. No, you got to know what that battery temperature is. If the truck's out all night in 10 degrees and you're bringing a nice warm shop, even if it's been in the shop for a couple hours, that battery has not warmed up very much. I always tell people if you use an infrared gun, shoot the side of a battery to get the most accurate reading you can. Some of the newer testers have an infrared gun built into them. Tells you to point at the battery and hit the button and it locks it in. But again, always shoot the side of a battery so you're getting as as accurate of a temperature of what that battery is as you possibly can. Never shoot the top of it. It's going to ask you what the CCA is, or MCA, or CA. Again, just make sure you're familiar with what your tester's asking you, so you fill that information in properly. If you test it at the wrong temperature or tested it with the wrong battery rating, you can very easily condemn a good battery or pass a marginal or a bad battery. So make sure you understand your tester. Go through and take a look at them. If they're all good, you're done. Put it back together. If you find bad ones, you have to replace them. And this is a good time why this is such a good, topic of get ready for winter. Don't wait for it to fail. If you test a battery and it's telling you it's marginal, or if you look at it and say, ooh, this battery is already 3 years old, according to our norm, we've gotten all the life out of it we're going to. Let's change it now before we take a chance on having a road call with it. And some things too is look at the batteries. Are they some oddball ones you acquired somewhere? This is a road service somewhere, and hey, these are some oddballs. I'm not sure where they came from. Or they're a weird rating that you normally wouldn't buy. Any of those things, again, good time to take them out. Don't throw them away. Those can be some very good trade truck batteries, or maybe use them in a yard dog or something like that. But you want to replace them all. Shop procedures are vary with different fleets. I am a firm believer to replace them all at once. Don't mean throw them all away, but you had 4 batteries, one of them's defective. Let those 3 that are good go through the recharge program, which we will be holding a webinar in the next couple of months on the battery recharge program. But go through the recharge program, match them up until you have another good set. That way, a week from now or whatever, a truck comes in that needs batteries, you can have a good set of recharge batteries you're comfortable putting back in. And again, they are a set. Next thing we want to do once we've done the batteries is we're going to check the charging system to the batteries. This is just a drawing of a typical voltage drop test using one of the electronic type testers. There's several different ones out there, or you can use an old-fashioned carbon pile. A little bit more hard to do with an old-fashioned carbon pile, but the test is the same. Is the first thing we're going to do is test our starter cables. Why starter cables? Because that's how most trucks are wired. They have main cables that go from the batteries to the starter, then cables from the starter to the alternator. Again, like Bob talked about before, the TMC spec for RP129 is you're allowed half a volt at 500 amps. So whether you're using an electronic tester or manual carbon pile, you're going to dial it in that 500, do your test, and as long as you're under 500 or under half a volt at 500, you're good to go. Now, I would still always go back and say, wait a minute. History says these things usually are good to, only a 0.3 of a volt drop. Why am I at 0.49 or whatever? Yeah, I'm still at spec. Boy, it sure still seems kind of high. Take a minute, go through it. What's the first thing I would do if my cables were out of spec? Clean and tighten. And if you did your job in the right order, you've already cleaned everything at the batteries. So next thing you would take things apart and clean up the starter. But we did the starter cables first. Next, we're going to do the alternator cables. Same way, simply now moved our large leads from the starter up to the alternator. And for this spec or this test, you're going to use rated output of the alternator, and you're still allowed that half a volt. So if you had a 100 amp alternator, you're going to load the cables to 100. If you have 150, you're going to load it to 150. Still allowed that same half volt, but it depends what your alternator is rated at. That's one thing you got to be careful about. If your truck came with only a 150 and thought, well, I'm going to put a 300 amp alternator on here, if you tow and upgrade your cables, you're not going to get the benefit of it. So again, make sure you check all that. All righty. Now that we've said it 15 times, we're going to have it as a pop-up question right quick. What is the spec for TMC RP29 for the cranking cables? Again, just hover over it and click on what you think the answer is. Again, we're making sure you're paying attention.
I got my question right, so.
I'll even answer it myself. give you just a few more seconds here or so, seeing how many have responded. All righty, let's see what those results are. Still had a few missed it. But yeah, TMC spec, that's, Technology Maintenance Council, RP, recommended practice 129. Spec is you're allowed half a volt at 500 amps. And thinking about that in some of Bob's examples before, says if we're allowed half a volt at 500 amps, how much would we be allowed if we pulled 1,000 amps? And the answer is 1 whole volt. So when we talk about now that voltage drop changes with higher current, yes, you pull more current, you're going to have more voltage drop. That's just Ohm's law. If voltage goes down, current must go up. So move on to our next one here of what else can you do to ensure a trouble-free winter? Review your specs. Things change. There's, several different manufacturers out there for starters, alternators, batteries. Are you speccing the right one? One of the best things I can tell you if you're not speccing it right now is alternators that have remote sense. What is remote sense? Typically, all heavy-duty alternators have always regulated based on what they see at the output terminal. So if you do have, bad cables, undersized cables, whatever, the alternator doesn't know. It says, hey, I'm putting out 14 volts like I'm supposed to. You may only be getting, 13.5 at the batteries. So with remote sense, it can actually sense directly at the batteries, or some of the OEMs run it to the starter and pick up voltage drop there, because at least they know they have the big cables going back. But you can help counteract some of that voltage drop, because again, wintertime batteries don't like to take a charge. They're like me. They don't like cold. So if you do have inherent voltage drop, it's going to be that much harder to charge those cold batteries. But gear reduction starters, different types of batteries. I still see a lot of fleets that spec the wrong batteries. They still look at high CCA as the solution. And for certain applications, you need the high CCA. A lot of them you don't. You lose a lot of other benefits with that high CCA versus a middle of the road where you have better reserve capacity. But you've got options now, flooded cell or AGM. They're still lead acid batteries, but they're different, slightly different chemistries, different way they're made. But look at the CCAs, look at the reserve capacity. What is the warranty? Obviously, the best warranty is the one you never use. But how well does someone take care of you on your warranty? Are they rotating batteries? One thing, too, is in the middle of winter, you want to make sure any of your batteries, whether from your recharge program or just from your shelf of new batteries, are they fresh? And are they 100% charged? One thing I see people get in the middle of problems with is either they put discharge batteries in, truck sits on the yard, or the other scenarios, they do go out there and jump start a truck, batteries were discharged because of parasitics or whatever, jump start them and send them on his merry way. That takes a long time for those cold batteries to ever take a full charge. So you can very easily send somebody down the road for a failure, because the first time he shuts that truck off, he still hasn't put any energy back into them. Again, talking about starters, gear reduction, is it the right kilowatt rating? You got to make sure you got enough cranking power. Does it incorporate the IMS or the integrated mag switch? What is your warranty? Some of the things, whether you get over crank protection, different packages, you may spend a little bit of money up front, but may give you a much longer warranty on the back end. One of the things that's nice about gear reductions too is, boy, they sure take up a lot less room, and you don't lose nearly as many sockets when you change them. And some other things too is the OEMs for alternators have spent a lot of time redesigning alternators, and I urge you to reach out to your representative from whatever company and help make sure you're speccing the right alternator. Sometimes you may want to go to a little bit less output, because where you operate your engine, you're actually going to get a better charge profile because it puts more output or has more amperage output in that RPM range. So don't hesitate to reach out to them and work with them. You're all set. Are you ready for winter? And one thing is, show a roll around charger here. If you have a vehicle, whether it's a liftgate, reefer, whatever, if it's in for a PM, boy, it sure can have big paybacks that while it's sitting in the shop, take your roll around charger, hook up to it, so at least when you park it, everything should be charged. That if everything's ready to go when it gets parked, I guarantee you'll have fewer problems down the road. What else can you do to keep your equipment ready? Depending upon fleets, some locations do have the ability to do shore power. If you don't, I'm not sure it's in your best interest to spec it because you're never going to take advantage of it. But if you do have electrified parking spots at your location, inverters that have built-in battery chargers, block heaters, fuel heaters, things like that, all those things can help. We talk about those power requirements in wintertime. When your biggest, actually the biggest factor on engine crankability is oil viscosity. So if you can keep that engine warm, it's going to be much, much easier to crank it. But you got to also assume that, hey, I'm only going to have that ability if I'm at home. So I still have to do all the other preventive, maintenance things and spec the right equipment. So when it's out on the road, I don't have problems. But again, onboard charging. The other thing too is, what causes a lot of the problems on these things is parasitic loads. That all vehicles have parasitic loads, but we have to manage them. And one of the biggest things that we've always had issues with in the industry, and that's how we got in the inverter business, is inverters keep drivers happy. They want all their comfort, features when they're out on the road. But we do have to manage that. Inverters are very power hungry. They can take a lot of energy out of the batteries when they're operating. They can also take a lot of energy out of the batteries when they're just sitting there. So not only you got to make sure what you're looking at for parasitic loads when they're sitting idle, but also what the LVD set point is. Again, we can do a lot more cycling, a lot deeper cycling in summer because those engines will still crank. But wintertime, you take it down that same amount that you're used to, you're going to do unnecessary damage to the entire electrical system. So you want to make sure you're looking at the right units on that. Make sure you got the right wattage. I see some fleets that buy some crazy wattage inverters, and some of it because they've bought, I'm going to say economy type units, and they're very overrated on their specs just because they derate so much. But easy rule of thumb is divide by 10. So if you have a 1500 watt inverter, it's going to pull 150 amps out of your batteries, while it's running at full output. So someone thinks, well, I'm going to put a 3000 on there. Well, now you're up to 300 amps out of your batteries possible. So you got to make sure you are properly matching that to what driver's going to need and what your battery pack can support. The other thing you got to look at, just like anything on these, is modified versus pure sine. Again, we talked about the shore power. Do you need or want that provision? What is the efficiency on it? The other thing too is you got to make sure your drivers understand that just because it's a 110 outlet in the sleeper, it is not connected to a small nuclear reactor. It's still 4 batteries that have to power all this. The other thing is, temporary use panels, and Bob's going to go into solar here in just a second. Oops, actually, I'm already talking. Oh, this is my last one.
That's, but that's all right. You're talking about one of those things that we can do to kind of help our systems, and solar has been something I've been getting really excited about, and I've been doing well speaking to customers about them. So it's such an effective tool because you're using the power of the sun to keep your batteries topped off. You want your batteries operating at 13.2, their maximum output. As we said before, in cold weather, that drops down. But adding a solar panel, and this slide here talks about a temporary use panel. We have a product called a solar dash, but it's something you throw in your dash, you plug into the cigarette lighter, and now you're offsetting some of those parasitic loads that Larry talked about. using the sun to keep that battery topped off. The battery topped off is not going to sulfate. It's going to operate better when needed. So this has been a great product for us. We call it a solar dash, in case you're curious about that. And there again, it's a temporary install. You can move it from truck to truck. We have a lot of customers that have what they call lot rot. So you buy a truck, you have it sitting out there, or there's a truck waiting for parts, whatever it may be. It's sitting out sitting outside for 30 days, whatever it may be. Well, those batteries are discharging as they're sitting there. So putting a temporary panel like this in the dash is going to keep those batteries topped off, so that when you do need to go use that truck, it's going to be available to you. We've had some good success with putting solar panels on tractors. We use them for lift gates, and we use them for the tractor install, as you see here. On top of the cowl there, I think this is actually one that Larry and I installed, but sits up there. It can be fastened mechanically, or by glue. We use a 3M glue on ours that sits down there. Very, very difficult to get off. We don't have any issues with them flying off or detaching, but we're able to use that sun to keep those starter batteries topped off, reduce the parasitic load. In cold weather, you're still getting sunshine, you're still getting some energy there. And I had a customer in Ohio in October that we installed 10 of these. And when we would install them and pull them out of the garage and put them on the lot, they had battery monitors there. And as we went from 12/7, the minute we pulled them out, there again, on an overcast day in October in Ohio, we start seeing it creep up 12/8, 12/9 over the course of half hour or so. So they are effective even in more northern climates, and even when the sun's not out shining bright. So I'm a Florida boy, but I believe that solar can work for everyone. So, and then of course we talk about the reefer install as well. We're able to, even with the tractor side, we're able to put a couple together. And in this picture here, you see that we have 3 put together, but we're able to change that 110 watt panel into a 330 watt use there. So you can put them on the front or the rear of the lift gate of the trailer, and it charges those lift gate batteries with the solar power as well. So that's been an effective tool for us. So solar wasn't what it could have been years ago. We wouldn't talk solar too much. I believe Larry would agree with me here. There wasn't 10 years ago, might not have been a thing, but now the solar panels have gotten to where they're much more advanced. They're able to capture that energy. And just a plug for us here a little bit, the controller that you use on the solar panels makes the difference. You buy a cheap solar panel, it's got a cheap controller, and it'll leak out as much energy as it puts in at nighttime. But our controller panels that we have are able to capture some of that, open up the gate and close the gate as needs be to keep that energy in place. So I have another question for you. Which one of the benefits, which is not one of the benefits a fleet could see from using solar? So if you take a minute here to answer this question as well, there again, hover over what you consider to be the right answer. Which one is not one of the benefits a fleet could see from using solar? And Larry, I'll let you answer that too. Give you guys a minute here to answer that. The first question they got all right. And Larry, they tripped on your question. We're going to see how they do on this one.
I'm pretty sure I got it right.
You should, huh? All right, we'll go ahead and see what we have here. Okay. So yeah, improved tire life. Probably not. Solar's not going to help your tire life too much. Somebody threw in there improved fuel economy. You're close to being right on that too. We haven't been able to really. There is some fuel economy that has been improved by, there again, having your batteries topped off, having your electrical systems work better. But it is is very marginal. Wouldn't you say, Larry?
Well, where we've really seen the fuel economy is EPU type applications, where
There
we
you
can
go.
put enough energy into those batteries to offset the EPU running. So it avoids the engine having to start up to replenish those batteries. So those we can, definitely tie to it. The other fuel economy is, if that solar's harvesting, you know, 5 amps, 10 amps, whatever going down the road, well, that's 5 amps, 10 amps that the alternator doesn't have to produce. So is there fuel savings there? Yes. I'm not going to tell you what numbers you could ever expect, but there is definitely fuel savings there. I don't want to be one of those people that, tell somebody, fuel savings, and if you put enough solar on there, your tanks are going to overflow going down the road.
Yeah. Well, very good. Thank you guys for answering those. So if you follow these simple instructions, you are ready for winter. Larry did a great job of taking you through the steps 1, 2, 3, what you need to do to check your electrical systems. Again, we would suggest a solar option for whatever you use. I think that's a real smart thing for your fleet. Thank you, guys. I'll let Larry go ahead and close us out here.
All righty. Well, thank you, Bob, and thank again everybody for attending. No matter what, we'll see if we got any questions pop up here, but please do not drop off until the end, because there is some survey questions, and some of that is we want to do these every month for you. I see some very familiar names, people and companies on here, so we're always asking you, what kind of content would you like us to do? Whether in webinars or some of, again, our customers that we can do some of this training in person too. So please do not drop off until we do those surveys. Let me check, see if we had any Q&A. One question came up is, talk about doing this in fall. When else should we do it? Now, we do this, very similar webinar in springtime. The two biggest times that the electrical system really needs to, have a good once over is spring before you go into the heat and fall before you go into the cold. So again, a lot of the same rules apply, that you got to make sure all these systems are ready to go. Again, there's also electronic testers that allow you to do battery bank testing as a whole, where you test all 4 batteries. That's great to do in between, but I'm still old school, and I would still much rather see people take everything apart, clean it, make sure it's right. You don't need to spend 3 hours doing it, but when you have all the batteries apart, clean them. I don't care whose battery it is, that if you let all the grease and gunk accumulate on top of batteries, they will self-discharge through all that. So you just added another parasitic. So I am a firm believer that, hey, while you got it apart, give them a good wipe down, put it back together, make sure everything's, bright and tight. Let's see if we have any others here. One is, suggestions are, what's a standard solar panel? It depends what you're trying to do. We've done everything from 20 watts to 550 watts. So yeah, for you just trying to offset parasitics on a trade truck, or offset, parasitics on a reefer. But one of the first things y'all's got to do is go out there and accurately take a measurement of what those parasitics are. Because one thing is, parasitics are there 24 hours a day. Solar only works for, roughly a third to half of the day, depending upon, where you are and time of year. So you may have to have 2 to 3 times as much solar, to put back what that parasitic takes out over the full day. I think that's all we had, but if you do have any questions, our Bob and I's contact information or bios are provided. Feel free to send us an email with any questions. Sometimes people don't always want to type in something live, but we will wrap it up. Again, thank you, and look forward to you on some of our future webinars.
Thank you very much.